For this double replacement problem, we were given lithium sulfide and silver nitrate. To start off, we're going to want to know if the two compounds are soluble or insoluble. So just looking, we can see that lithium is an alkaline metal, and we know that because if we look at our periodic table, lithium is right here. So we know that's an alkaline metal, which means that it's soluble. But looking at silver nitrate, we're going to look at our solubility table, and we're going to look and we're going to see that there's no silver, but there is nitrate right here. So we also know that that is aqueous, or soluble. So now that we know that, we're going to draw it out. So I like to draw two beakers. And in the first beaker, we have lithium and sulfur. So because there's two lithiums here, we have to draw two lithiums in here. So we have lithium and sulfur is a -2 charge, and lithium is a +1 charge. And these little triangle shapes are water molecules. So the tip is oxygen, which is a negative charge, and the 2 points on the bottom are hydrogen, which is a positive charge. And because opposites attract, the negative oxygen is attracted to the positive lithium, and the positive hydrogen is attracted to the negative sulfur. Same thing over here. We have one silver and one nitrate, and you may be wondering why there's two, but you'll understand it later. Same thing with the water molecules. Because Ag is positive, the oxygen will be attracted to it, and because nitrate is negative, the hydrogen will be attracted to it. So now we're going to make an element inventory. So basically this just counts up how many of each element we have. So we look at lithium, we have 2, sulfur 1, Ag is 1, nitrogen is 1, and oxygen is 3. So we have nitrogen and oxygen because it's a polyatomic ion. So we're going to separate the nitrate into nitrogen and oxygen. And that's the only thing you have to really know for the element inventory. So now the next step, we combine them both together. So we pretend that we pour both of these beakers into one giant beaker. And what's going to end up happening is the two cations are going to combine with the opposite anions. So lithium is going to end up combining with nitrate, and silver is going to want to combine with sulfur. But to make sure that they satisfy each other, we have to draw it out. So we're going to do a dot diagram. So we draw sulfur, and we know that has a -2 charge. So we draw 6 valence electrons, and we know that Ag has a +1 charge. So we have the 1 here. If this Ag gives sulfur its valence electron, Ag will be satisfied, silver will be satisfied, but sulfur will not. So we have to add another silver to satisfy the sulfur. Now that is satisfied. So going to lithium nitrate, we know that nitrate has a -1 charge. So we draw 7 valence electrons. And we have 2 lithiums, which each have a +1 charge. So if this lithium gives its valence electron, which it will, to the nitrate, this group will be satisfied. But this lithium is still looking to get rid of its electron. So we're going to have to add another nitrate. And once we do this, it gets rid of its electron, it gives it to the nitrate, and that's satisfied. But here's the important key part. Because we added another silver here, because we added another nitrate here, we have to go back to our original beaker, and we have to add it in there too. And that's why I had 2 silvers and 2 nitrates, which also shows up in the equation. It'll be 2AgNO3, because there's 2 silvers now, and there's 2 nitrates. So this represents 2 groups of this. So now we're going to make our second element inventory, and this is just to add the changes that we made. Sorry, I'm kind of sick. So lithium is still 2, sulfur is 1, but Ag is now 2 because we added it here. Same thing with nitrogen and oxygen. Because we added another nitrate, we have 2 nitrogens now and 6 oxygens. So that's why that's like that. Now to the final part. We have to make the balanced formula, the net ionic form equation and the complete ionic equation. So let's start with the balance formula. To start this off, we're going to rewrite the original equation that we have. So we're going to have Li2S, which is aqueous, plus 2AgNO3, which is aqueous. And remember, we have the 2 here because we added 2 silvers to the original beaker. So this transforms into our balanced equation, which is the new compounds that we made in the giant beaker. So here we have 2 Li NO3, which is aqueous. And the 2 is here because there's 2 groups of these, not 2 Li's. And plus Ag2S solid. Now, there's not a big 2 here because, yes, there are 2 silvers, but there's only 1 sulfur. So for this, we're just going to write a little 2, which represents the 2 silvers. Now, we're going to write our complete ionic equation. For the complete ionic equation, you want to write each element by itself. And you want to set them all as aqueous because they haven't combined with anything yet. So we have 2 Li because there's 2 Li's in the original equation. This is the original equation setup. And it's aqueous because they're all aqueous. We have S minus 2. We have 2Ag because there's 2 silvers. And we have 2 NO3 minus 1 aqueous. So now if we have our, to have our complete ionic equation of everything, we still have 2 Li plus 1 aqueous, and we still have 2 NO3 minus 1 aqueous, and that's because unlike, I'll get back to that, and then we have plus Ag2S solid. Now, you might be wondering why this combined in the end, but this stayed separate. That's because when these two combined, they fully combined, so they made a solid. When these two came together, they didn't make a solid. They both stayed aqueous, even as they were combined. So they still dissolved in the water. So because of that, we don't combine them in the complete ionic equation. Ooh, sorry. So now for the last part, the net ionic equation. For the net ionic equation, the only thing we're focusing on is the Ag2S solid because they made a solid. So we're going to write it again as separate elements. So you write 2Ag plus 1 aqueous, remember, because they haven't combined yet, plus S minus 2 aqueous. And for our final equation for the net ionic equation, we're going to have Ag2S solid. And 2 is because there's 2 Ags, not 2 sulfurs. I hope this was helpful. Thank you.